Good morning, fourth graders. This week we are going to be learning about hurricanes. And in lesson 11 in our Journeys book, which is on page 320, we are going to be reading an informational text. And an informational text is one that is a nonfiction, which means it's true and has informational facts throughout the story to help you understand more about hurricanes. So this is called Hurricanes, Earth's Mightiest Storm, written by Patricia Lauber. The making of a hurricane. Great whirling storms roar out of the oceans in many parts of the world. They are called by several names. Hurricanes, typhoon, and cyclone are the three most familiar ones. But no matter what they are called, they are the same sort of storm. They are born the same way in tropical waters. They develop the same way, feeding on warm, moist air, and they do the same kind of damage, both ashore and at sea. Other storms may cover a bigger area or have higher winds, but none can match both the size and the fury of hurricanes. They are Earth's mightiest storms. Like all storms, they take place in the atmosphere, the envelope of air that surrounds the Earth and presses on its surface. The pressure at any one place is always changing. There are days when air is sinking and the atmosphere presses harder on the surface. These are times of high pressure. There are days with a lot of air is rising and the atmosphere does not press down so hard. These are times of low pressure. Low pressure areas over warm oceans give birth to hurricanes. Now you can see this picture right here, and this box of text happens to be a question, but this would be considered a caption because it's talking about this picture. So let's move on to the next page. No one knows exactly what happens to start these storms, but when conditions are right, warm, moist air is set in motion. It begins to rise rapidly from the surface of the ocean in a low pressure area. Like water in a hose, air flows from where there is more pressure to where there is less pressure. And so air over the surface of the ocean flows into the low pressure area, picking up moisture as it travels. This warm, moist air soars upward. As the air rises above the earth, it cools. The cooling causes moisture to condense into tiny droplets of water that form clouds. As the moisture condenses, it gives off heat. Heat is one kind of energy. It is the energy that powers the storm. The clouds are the source of the storm's rain. Down here, which is covered by my picture in your book, you will see that it's another caption, and it talks about the birth of a hurricane. The low pressure area acts like a chimney. Warm air is drawn in at the bottom, rises in a column, cools, and spreads out. As the air inside rises and more air is drawn in, the storm grows. The air being drawn in, however, does not travel in a straight line. The Earth's surface is rotating, and the rotation causes the path to curve. The air travels in a spiral within the storm. In the northern hemisphere, the spiraling winds travel counterclockwise, the opposite of the ways of the hands on a clock move. In the southern hemisphere, they travel clockwise. Most of these storms die out within hours or days of their birth. Only about 1 out of 10 grows into a hurricane. So you can see this kind of looks like a fish tank, and it gives a diagram of what it looks like when a hurricane is being formed. Again, we have a caption to this picture below. Moving over to the next page, no one knows. As high wind develops, air pressure falls rapidly at the center of the storm. This low pressure area is called the eye, and it may be 10 to 20 miles across. The eye is a hole that reaches from the bottom to the top of the storm. Winds rage around the hole, but within it, all is calm. Winds are light, the air is clear, with blue sky or scattered clouds and sunshine above. People caught in a hurricane may suddenly experience calm air and dry skies. Sometimes they make the mistake of thinking the storm has ended, but it hasn't. The eye moves on, and the second half of the storm arrives with winds blowing from the opposite direction. Here are some weather instruments they use with hurricanes. Ancient peoples lived through great storms. They looked for signs that would help them predict the weather. They tried to explain the weather they experienced, but no one can really study weather without measuring what is happening. The instruments to make such measurements were invented 300 to 400 years ago. Modern versions of them are still used today. This first one is a barometer. A barometer measures air pressure. Rising air pressure tells of fair weather, while falling air pressure tells of stormy weather. This kind of barometer is often seen in homes and schools. This is a hydrometer, measures the amount of moisture in the air, the humidity. Warm air can hold more moisture or water vapor than cold or cool air. When warm, moist air is cooled, water vapor condenses, changing from a gas to a liquid. That is why a glass of ice-cold soda seems to sweat in the summer. Warm air around the glass is chilled, and water vapor condenses out of it onto the glass. An anemometer measures wind speed. The rate at which its blades spin outdoors is registered on a dial indoors. In the 1938 hurricane and other violent storms, anemometers have blown away, making it hard to tell what the highest wind speeds were. And then a thermometer. A thermometer measures temperature. World names. In the Caribbean Sea and the North Atlantic, Earth's mightiest storms are called hurricanes, after a Carib Indian word for big wind. In the Pacific, they are also called hurricanes if they occur east of the international dateline. West of the dateline, they are called typhoons, from Chinese words for great wind. In the Indian Ocean, they are called cyclones, an English name based on a Greek word meaning coil, as in coil of a snake, because of the winds that spiral within them. The storms also have a number of local names. Many Australians, for example, call them willy willies. The name probably began as a whirlwind, which became whirly whirly, which became willy willy. And again, you will see a caption explaining this picture. Into the eye of the storm. Today, rugged plains carry many instruments into hurricanes as they near land. The instruments measure winds, temperatures, and humidity. They measure the water content of clouds. They photograph the inside of hurricanes. They record radar images of the storms. In April 1960, the first weather satellite rocketed into orbit. Now scientists hope to find and track tropical storms before they neared land. They were rewarded almost at once. A few days after its launching, the satellite discovered a typhoon in the South Pacific. Satellite instruments do not see into the heart of a hurricane. That work is still being done by planes. Satellites show the size of the storm and its growth. They show changes in the size of the eye. If the eye is growing bigger, the storm is weakening. If it's growing smaller, the storm is strengthening. Most important, satellites can pinpoint the location of a storm, record its speed, and track it closely. Information from ground stations and ships, from hurricane hunting planes and satellites. Forecasters have more information than the human eye can grasp. But since 1960s, they have been able to feed all this information into computers. Now they can create computer models of hurricanes. They can compare a hurricane with similar ones that occurred years earlier. Forecasting just one storm may involve several million bits of data and several billion mathematical calculations. Huge computers do the work. Today, no one who reads a newspaper, listens to radio, or watches television can be taken by surprise when a hurricane strikes. Although forecasters cannot say exactly where a hurricane will come ashore, they do know which areas will feel the storm. They can warn people in its path, as they did with Andrew in the summer of 1992.